My name is João Brau. I'm a postdoc researcher at CEDRI, and today I'm going to present the first module, which is entitled Python Hands-On Introduction to Data Science with Python. So, what we're going to see today, this module is going to be, as the others, will be divided into two parts. First, I'm going to explain some theoretical parts regarding Python and data science, and after that, we are going to do some exercises together. Okay. Since we have different levels of people that are attending to this course, I think it's the best approach for the first module is to do it together, so I can show to you to the beginners also in data science in Python what are the possibilities. I will not be able to show everything, because Python is a very, how can I say, complex language. And data science also is a very complex area of knowledge. Okay. Regarding the practical part, I prepared a mini project. We are going to scrutinize a real data set of the Titanic accident. Okay. So I think it's a way to motivate you of what you can do with data science. Okay. So some considerations and objectives before we start. And this is even a little funny, because I sent to a colleague of mine and I asked him, do I show this to them or not? And he said, don't do this, because maybe you will demotivate them. But I don't think this is the idea. The idea is to actually motivate you, because this is a very complex subject. So in my perspective, we should be realistic. So in this module, you'll not become experts in Python and data science. So the idea here is just to introduce you. So don't feel like, how do you say, don't fear this, okay? And with the other modules, you will get better and so on. So if you don't understand everything, you can also ask me and you will get there, okay? So this module will not transform you to an expert, okay? And I will not be able to cover all the aspects in data science and Python. But this module will present some fundamental concepts, okay? I will try to show the possibilities, but what we can do with Python, and I will prepare you for your next modules, okay? And then you're going to learn more things. So before entering Python, what is data science? So I took the textbook definition to start, right? So what is data science? It's a multidisciplinary science that uses scientific methods, processes, and systems to extract knowledge and to make some decisions regarding this data, okay? And usually it follows a cycle, which we call data science cycle. This figure here, I took from the United Kingdom National Cancer Research, because just to show you that this type of cycle is used in the academia, in the industry, and so on. Usually, this data science cycle, this life cycle, it changes based on based on the subject that you working on. So usually, when you work with academia, you have all these steps, which the first is called data generation or collection. Usually, this step is similar to all of the life cycles that we can encounter on the internet, on the academia, on the industry. However, the last steps, it can change. So if you work in the industry, instead of data sharing, usually you have deployment. So to be very clear here, what are the steps and what are the differences? So the first step is usually you have to collect your data. So either you can generate it or you can collect it, okay? After that, you will clean the data, because usually, or I would say very frequently, the data is not in the format that you need, that you can use to work. So it will come with corrupted data or missing or gaps in your data. When I say this, imagine that we extract all the students' information from IPB. Not all of the attributes and observations will be correctly placed. So you will have some corrupted data regarding the age of the students or the courses and so on. So even before starting to analyze the data or scrutinize it, you have to clean it and you have to prepare your script. So one of the most important aspects is cleaning and preparing, okay? So the next step usually is data exploration and analysis. So Here, it's a very also broad concept, but basically it encompasses the preliminary analysis. You will try to understand the patterns in your data, okay? Then you try to, after you understand the possibilities, what the patterns are in your data and what you want to do, you can try to do some predictive modeling. As I said, this figure here was took from the National Cancer Research in United Kingdom. So the idea of them is to try to predict if someone is going to develop cancer according to symptoms and so on. So it's a how can I say logic that they will try to do some predictive modeling. Okay, so it goes to machine learning, which you will learn in the next modules. Okay. And then you can, usually it comes also the interpretation to make decisions. You try to visualize your data. So you try to make some tools and so on to visualize. When you work in academia, the idea is to share the ultimate goal. One of them, you can also deploy or try to generate some kind of artifact or some technology, but the main idea, I would say, is sharing. Okay, share with the other researchers. What are some common applications for data science? I took some that I think it's more relatable to us, like recommendation systems. So Netflix, Spotify, and YouTube, they use data science and machine learning, deep learning, to try to develop some recommendation systems. So I don't know if you already noticed, but like Netflix, based on the movies and series that you watch, it tries to recommend other movies that are similar to what you are watching. So this is the same for Spotify, based on what you listen and the genres of the music and so on, or podcasts, and YouTube as well. You also have fraud detection for banks. So based on all the transactions and different types of data, and it's a lot of data, you can also try to develop some fraud detection modules, or I would say technologies, right? You can try to also do forecasting in logistics, in the retail sector, and so on. Medical diagnostics, as we see in this data science lifecycle. And you also can do some social network analysis, and this is when it comes all the polemics that we have in social networks and stealing of data and so on. That can happen now and again. Okay, so why Python from data science? So until now, we understood what is more or less data science. But why Python and not another language, programming language? So we have several motivations to use Python and not the other languages. And I would say the most common ones are, it's because it's a very easy to learn language with a hashtag. It's easy to learn, but very difficult to master, okay? But don't be afraid of this, okay? So the idea is to be easy. And it's very accessible. The community is very active. You have lots of documentations and libraries that are with active, how can I say, maintenance and updates and so on. It has a growing adoption in the industry and academia, and even with some examples. We have some essential libraries that I grouped to do data science in Python, which I would say it's NumPy, which is basically a library for numerical computations, and they even have scientific publications. They have research papers using this library. Scikit-learn, basically for Python, scikit-learn, I would say it's like the mother of machine learning. So it's a scientific library that has lots of machine learning models, modules, deep learning, and so on. And they also have scientific publications. So it's reviewed by the community. Okay? We have also some libraries for data visualization. So in this regard, Matplotlib is the most popular one. And it's a very customizable library in a way that's very similar to Python. It's easy to plot like information and so on, but it's very difficult to be an expert because everything is customizable, Matplotlib. You can customize everything in a plot. They were developed to be static graphical library. So you can generate static images with very high resolution, okay, with your data. So you can plot like scatter plots, histograms, box plots, everything that you can imagine, you can do it in Matplotlib. If you see this logo here, it's another very popular library for visualization as well, which is called Seaborn. It was developed on top of Matplotlib. So I would say the backend or the engine behind or below the Seaborn is Matplotlib. So if it uses Matplotlib, why I show this? It's because Seaborn is, the community likes it because it has a more, let's say, beautiful graphs and so on, and it has other features as well. So whenever you see some works in this area, you will see either Matplotlib or Seaborn, or even the two of them working together. So, well, and besides these, you can also have very common in this area, pandas. So pandas is another library, which is a library for data manipulation. So when you work with data science, we work with I would say usually with data that is very, how can I say, with several types of data and a lot of observations. So maybe millions of data or 1,000, 100,000. So usually it's very difficult to perceive this because it's very abstract. You cannot imagine all of this. So pandas, it's a library that it tries to help you manipulate all this data. So in a way, it's like a data table management system, okay? I will show you how it works. So these are the most essential libraries for data science, okay? Another way to, yes, just another thing. Regarding NumPy, usually, like pandas, I said that it's a data management library. Just out of curiosity, pandas was developed on top of NumPy. So the below engine is also NumPy. Why is that? Because NumPy, it's very efficient for computations with big data, basically. Because it's implemented in C. Okay, so it's C is another programming language that is very efficient for computational tasks. So this is, I would say, is one of the most essential when you work with big data. Otherwise, your code is going to be a little slow. But if you are using Scikit, if you're using pandas and so on, below NumPy is running. Okay. So what are the fundamental characteristics of Python? It's an interpreted language. Okay, so the code is executed line by line. And this is really good for data science because you don't have to, like, every statement that you write or you want to change and try another visualization. So you don't have to compile all the code again and run again. It takes a lot of time. You just execute all the scopes that are needed to generate again your output. So it's easy to develop and to try new plots and new models for machine learning and so on. It is cross-platform, so you can develop in Linux, you can develop in Mac, which is Linux, and you can develop in Windows and so on. Okay? It's high level, and this is interesting. I mentioned to you, oh, NumPy is very efficient, so why Python is not C? Why C is not used for data science? Because C is a middle level programming language. It's how can you say, the level of abstraction for machine code is not that high. So Python, it's a programming language that resembles the English or our human language. So it's much better to work with data science because you don't have to worry about all the low level, middle level computer engineering, okay, or computer science, okay? So you just have to worry about data science. So that's why it's also one of the motives that Python is used. And it follows the iconic philosophy. So one of the guys that was the inventor of Python, it's called Tim Peters, and he's basically dictated 19 principles to develop Python. I will not read everything, but this is an Easter egg. If you import this in a Python code and run it, it's going to print the Zen of Python. So basically, these are the directives that they follow to develop the Python, which is maintained for a long time. So we are in the Python 3 version now, and it had 2 and so on. So like the first 2 sentences, beautiful is better than ugly, is a very primitive statement, but it's one of the statements that they follow to develop Python. And explicit is better than implicit. And this is a very strong directive for a programming language. It's very important for you to be for the information to be explicit. Otherwise, when another developer or another person will try to access a code of another person or a program and so on, if it's implicit, it's difficult to understand. Maybe it will have more than one meaning. It's going to be ambiguous. So just out of curiosity, it follows this philosophy. So when we talk about Python and developing, where can we develop of development environments? Okay, we call it IDEs, which stands for Integrated Development Environments. Okay, so it's different platforms for you to program and run your code and generate the results. Okay, I also grouped some main options for you to start working, and in this module, we are going to use one of them. I don't know the others, okay? The other modules. So the main options. Well, Google Colab, it's an option that is interesting because you don't have to install anything. You just create an account and it's going to run in their servers, okay? Of course, I think there are some features that are behind the paywall. I don't know, didn't use too much, but it's also easy to share. You have the access of their GPUs and so on. So I would say the most easy one to start programming is Google Colab, okay? You have Jupyter Notebook. This one, for data science, machine learning, and so on, I think it's my favorite. And this is the one that we are going to code today. Why is that? Because it has an interactive cell interface. The others also have, but this is more, it was developed for this. Like one of the objectives of Jupyter Notebook, it was to have an environment that you can organize by cells. You can write like documentation, and in the same cell, you can write your code, and if you execute it, it will generate an output for this cell. I'm going to show you this later. And then you have other IDEs. For example, you have VS Code. VS Code, which is this symbol here. Let me just clarify here. So this logo is from Google Colab, and then you have Jupyter Notebook, which is this one, and then you have VS Code. VS Code is from Microsoft, and it's VS Code is for several languages. It's not only for Python. Okay, so you can program in Python if you install some extensions to support Python. Okay, I would say this is more advanced, and it doesn't mean that you will have more rewards. Okay, this is just a personal option. You have also PyCharm. So PyCharm, it's from JetBrains. It's a company that's and PyCharm is the IDE to program in Python. You have the community edition for students, which is free. You just have to renew it every year. And you also have the professional edition. I would say, as this graph shows, it has a lot of potential, like a lot of tools, and to really help you to be very good developer in Python. However, you have to know how to use it. It's a really, I would say, the learning curve. It's very steep. Okay. Because you can be overwhelmed if you try to do everything in PyCharm, because you have lots of things there, okay? And then you have Spider. Spider is even funded by the Zuckerberg Foundation, if I'm not mistaken. I would say it's, if I would make some comparison to another software, I would say it's like a MATLAB. The way that you program is not like a MATLAB, but the interface, so it was, for me, it reminds me of MATLAB, okay? So, basically, all of them are free, or either they have a free version. Okay, so I took this image from Jupyter's website, and as you can see, there's a graph that they show that show basically the ease of use across the power, the processing, not processing power. This is in abstractions, like how many capabilities you have in this IDE, and they Oh no, sorry. This I took from Spider website, not Jupyter. And then they're trying to say that, look, if you want to have like the middle level, we try to make some commitment with our ease of use our software, which is Spider. We are going to use this one, which is the most easiest. Okay. The easiest, I'm sorry. So, I will try to cover some basic, how can I say, some basic concepts from Python. I will not cover all of them, okay? But just like the beginning for you to accompany me when we do the mini project. Okay, I will give you also some time for you to run the code also in your computers and so on. But I will try to program here and explain line by line what we are doing. And then I give some time for you to also do it, okay? But before we do this, I have to explain some things, okay? Because I don't know if everyone knows how to program or programming like in a object-oriented programming interface and so on, and so forth. So what is dynamic typing? And Python has this. It means that whenever you, it means that the variables, they will assume the type of the data that you basically assign to it. So it's different from other programming languages where they are very, how can you say, strict regarding it. So other programming languages, if you want to declare a variable as integer, if you want to like store the integer value to a variable, you have to explicitly write, and this is an integer variable, and it's going to receive an integer value, right? Variable and receive integer value. In Python, it's more easy. You don't have to specify this. The interpreter from it is going to do this for you. So if I want to store an integer number like 10, as this, can you see this? So if I want to store an integer variable in Python, I don't have to say, look, compiler or interpreter or something like that. This is an int, you have to declare this an int. No, Python does this for you, which is called dynamic typing. So if you write 10, it's going to assume that this variable is an integer. But maybe you change this to receive another value, like you run some statements and now you want to store a float, which is a floating number with a, basically is a number with decimal, forgotten English.
Decimal digits.
Yes, decimal digits, thank you. Imagine that now I want to store a value that is a float. We call float in computer science. Basically, the interpreter is going to interpret this for you. It's going to say, now it's not an integer, now it's going to be a float. Okay? So for you to understand what is happening, you have to follow the logic of executing. So it's a sequencing logic to understand what you have in a specific variable and so on. Okay? So you have to have some considerations when you think in dynamic typing. Because when other programming languages were invented, they were strict to avoid problems. If you let everything like free as this dynamic typing does, you can create lots of problems because developers can make mistakes. Okay, so you have to have some considerations. You have to be careful with this type of thing because the variable is going to change in the middle of the code. You have to know this. Okay, otherwise you can create problems. So, and also because Python is interpreted, not compiled, you can have runtime errors. What does this mean? It means that, like other languages, you write the code and then you compile it. What is a compiler? It's basically, between codes, is a program that will read your code and say, okay, you wrote correctly. This code is going to run correctly. It doesn't mean that it will work in the way that you intend to, but at least you wrote it correctly. And then you can execute it. Python's not like this. You don't say to a compiler to see this code was written correctly. No, you write it and it will try to run immediately. So if something was written wrong, it's going to have a runtime error. That's why it's on the run. Okay. So what are the advantages considering this topics here? You can have some concise code, you can develop rapidly, and this is also very correlated with problems. So you have to be careful. If you write very fastly or quickly, you're going to insert bugs. And you have flexibility. And you're going to see this when I show the Jupyter notebook. Okay, this flexibility is very interesting. Well, now that you understand that the interpreter has a dynamic typing feature, you have to understand how the interpreter understands what you are writing, okay? And we have what we call indentation and scopes. This is important as well. What is indentation? It's how you format your code. So in some languages, not Python, you have to have some kind of character that says to the interpreter or to the compiler, look, I finished my statement. So now you can try to read it and execute it. Python doesn't have this end character to the interpreter to see, look, you finished your statement. No, what it uses is the indentation. So it's very important the code needs to be formatted correctly. Otherwise, it's not going to run. And this is very, very important for people that likes to program in Notepad and so on, because you don't have to have an IDE to program in Python. You can program in Python in your with a pencil and a pen. You can do this, okay? But to be executed, even in Notebook, okay, in a Notepad in Windows, but to be executed, it doesn't like generate errors and so on. You have to follow indentation, which is mandatory, okay? And some people that likes to program in Notepad, they have some issues because you have to follow the convention, which is by default 4 spaces. So whenever you imagine that you have the main scope, not scope, you don't think in scope now, I will get to it later, but imagine that you have your main script, and you didn't enter in another, how can I say, function, you will understand later. You don't have to write any space to create another indentation, but think that in the middle of the code, you are going to call a function, which is similar to mathematics. Function is something, is another code that is stored in another script, and there's an objective for this function, like, I don't know, multiply 2 numbers, and then you call this function. Let me write it to be more clear. So imagine this is my script, okay? So this is the first line, and then you have the second line, third line, fourth line. This is what we call the global scope, okay? And in a line, I call another function. I don't know, let's say add x1, x2. Okay, so it expects 2 parameters, 2 variables, and it's going to return. Let me make it more explicit. It's going to store it in another variable, let's say g. So g receives the output of this function. When you call this type of function, it's going to be stored in another part of your script. It can be another module, it can be another file, it can be in the same file, but in another part of the code. So when the interpreter sees this, it's going to go to the address where the function is written, okay? But when it does this, it's going to change the scope. It's going to go to a local scope instead of the main one. And how the interpreter knows this, that is a local scope, or it's a global scope and so on, that's why you have indentation. So when, like this, let's see this code here. I wrote a conditional statement here. Don't worry too much about it, okay? Basically, what I wrote here is if it's a conditional statement, it means that I'm testing if the variable is more than 10. It's just this. If it is, it's going to enter inside of the if, but it's a different scope. You see? Because if this is false, it's going to continue on the global scope. Was it clear regarding this? Do you have any doubts? So it's just a way to the interpreter to understand that, like, if this condition was true, you have to enter its scope, its indentation. So for you to understand this, to be inside of the if, you write 4 spaces by default. Of course, that if you do this in an IDE, it's going to do for you automatically. When you write double points and you hit enter, it's going to just do the tab for you. Okay, but it's just for you to understand. So the scopes are going to be changed whenever you call functions or you write statements that and so on, or for loops. It's the way it understands the code. Think of as a formatting your document. For you to understand your document, it needs to be formatted. Otherwise, it's a mess. Okay. Do you have any doubts regarding this? You can ask if you need to. Okay. Before I enter data structures, because there are some students that they don't know how to program in other languages, so you can have some doubts regarding what are variables and so on. So before we enter data structures, which is a little more complicated, let's think about the primitive types. What are these? So whenever we think about programming languages, we think about variables. Variables can assume different types of values. So as I told you some minutes ago, we have like integers. So integers is a type of data, right? You can have floats. You can have also characters. So imagine, let's say the x again is 10. So this is an integer. We can have y to be 2.5. This is a float. We can have, I don't know, c to be c, a character, a letter c. So you have different types. So these type of variables that are like, let's say, the default ones, they call it primitive types. But you can have more complex variables. And this is what we call data structures. So I will not enter into this because this is it's not necessary for the module. Okay, for the it's going to come as the necessity arrives. Okay. But you just have to understand that you have some primitive types that describes the most common types of data, such as numbers, letters, Boolean logic. Let's say, I will write another variable. Let's say that I write is true, receives true. This is a variable. What is the type of data here? This is a Boolean type. Because from Boolean logic, you can have either true or false. And I'm assigning true to this variable. So is true is receiving true. So maybe later in the program, I can check, is true true? If it is, it's going to enter a different annotation, a different scope, okay? But this is just to make it clear to you that you have different types of variables. These are the primitives, and these ones are more complex, okay? What are the data structures in Python? The native ones, without going to the libraries, because before in some slides, I showed you some essential libraries for data science. These libraries, they implement even more complex data structures, okay? These are the ones that come with Python. We have lists. What lists do? They are ordered and modifiable collections. Whenever you want to make a collection of data and you need it to be ordered, you can declare a list. How can I do this? I will write it here. You have to obey the syntax of the language. Similar to English, you have to obey the grammar. You can also have syntactic errors here. You have to obey the way it was defined. So in that example, I created a variable called numbers. So this is a variable, and it's going to understand that it's a variable because I'm writing here the equal sign. It's going to receive something, and I want it to be a list. Okay? How the interpreter will know that this is a list? Because I'm going to write in square brackets. Yes. So if I write like this, the interpreter will know that this is a list. And this list, it has its features. It offers some some functions and some attributes that will help you to manage lists, okay? So it's a library from Python. So imagine that I want to store several numbers. Don't think of the, how can I say, the motive that I'm doing this. You just have to understand that this is available to you. And maybe in the future, as the necessity arrives, maybe you're going to use a list, okay? So you can have collections. And here the interpreter will see, okay, I have a list of 5 integers, and the contents are 1, 2, 3, 4, 5. Okay, I can access, I can add a number, for example. How can I add another number to this list? In the next slides, I'm going to explain how these complex objects work. But for now, you have to understand that these complex variables, they have methods. We call it methods. Basically, they are actions that they can do if you use these type of data structures, okay? So if I use lists will provide me with some methods to help manage lists. One of them is append. And how do I access these methods? And how do I know what are the methods that they offer? So I assume that you are going to, some doubts are going to appear in your mind, like where you're taking this from and so on. So let's proceed slowly, okay? Don't worry and don't be afraid. So regarding the methods, where do I find them? What are them and what they can offer and so on. Okay, regarding this, you need to check the documentation, okay? With time, you're going to basically memorize everything. If you use lists a lot, you're going to remember what they can do to manage lists. But if you don't know, I'm telling you now that lists has a method called append. And what it does, it appends a number to the list. It's going to put a number in the end of the list. It has others. It has methods to remove items from the list. It has methods to search something inside the list. So imagine everything that you can have as a necessity to manage lists. Maybe maybe the developers already think of it and already implemented this method for you. Okay. So how do you know? You have to check the Python documentation and see what they offer to use lists. Okay. Any doubts regarding this? Because this is a lot of information. No? Okay. So as you can see here, I am calling a method, and to answer the question, how do I use it? Whenever I say methods, it's because it's a part of an object, and list is an object in Python, okay? You access by writing the name of the variable, okay? And you write dot. Dot, the interpreter will try to find what are either the attribute or the method from this object. What is an attribute? Can be another variable inside this variable, okay? We will get there, don't worry. But just for now, you have to just memorize that if you write for an object, if you write the name of the variable and you write dot, the interpreter will try to find either a method or an attribute from this object that you wrote, okay? So with that said, let's go to dictionaries. Dictionaries is another data structure from native Python. What is that? There are pairs of key value. Okay, and how the interpreter knows what is a dictionary? It will understand that the variable is a dictionary if you write in curly brackets. Braces. Really? Oh, okay. I thought it was this curly brackets. Okay. Sorry about that. Braces. So if I write like people, and then I write the assignment operator here, which is the equal sign, it will, if I don't write anything else here, it's going to generate a runtime error. But however, if I write in braces, it will understand that it will expect a dictionary, okay? And it's basically there are pairs of key values. So if you want to have a dictionary, you can have it. Imagine that I want to like store information from a student. I can have a key written as name, and then I can have its pair, which is a value, okay, which is the name of this student. I can put it like, I don't know, here with Anna, so it's Anna, okay? And this doesn't mean, this is not, how can I say, limited to just one key value pair. You can have lots of key value pairs, like, I would say the limit is your RAM memory of your computer. Besides that, you can have, this can be even more complex, but I'm just saying to you, just to understand that these, you can, I would say the limit is your creativity. You can have a dictionary inside the dictionary, okay? You can have this. So let's go to the, and also similar to lists, you can have attributes inside of the object dictionary. If you write dots, you can access its attributes. What are them? Don't worry about this now. I just want you to understand the concept. And you can also have methods. Imagine that you have a very big list of students, like you guys here. You have names, you have ages, you have several things. And then imagine that I have a variable, a dictionary that has your information in it. And I want to know, to search a specific student. The dictionary has a method to search, to access the information by the key, not the value. So if I write, I don't know, a specific name like mine, Joel, I can write people dots. I don't remember exactly the method that searches, but there's one that you can even access via indexation. But I'm not entering into these details now to not overload you with information. But you have methods to search it, you have methods to access it, you have methods to add new students, to remove, you see? So this is a way to manage dictionaries, okay? You have tuples as well. Tuples, what are tuples? They are ordered and immutable. This is very important. This is the difference between tuples and lists. Both of them are ordered. However, you can modify after declared the lists and the tuples. No, it's the tuples. They are immutable. After you declare them and you assign a value to it, it's going to be the same until its life, you say, when it's not more declared, okay? And why do you have this? Why do you use it? You have several modes to use tuples, okay? And usually, maybe in your code, you have some information that you want to make sure that it's not going to be changed, either by error from the programmer or the function and so on. You declare a tuple, and the interpreter will make sure that it's not going to change. If something happens, it's going to generate an error because maybe the function will try to alter the data inside the tuple. It's going to say to you, you try to alter the data from a tuple. This is wrong, and it's not going to work. So it's a way to protect your data, either from yourself or from the libraries, okay? Sets. Sets, think as a bag of marbles, okay? It's basically, it's a collection that is not ordered, but you have unique items. You cannot have repeated. So inside the marbles, you can have only one marble of each type. This is a set, okay? What is the use of this? Like one application, you can have several, but one application that I can think of is, imagine that you are trying from a data, you try to access only the unique items. So whenever you try to add new items, it's going to keep only the unique ones. The others, they are going to discard it. So it's an application. But the creativity is the limit, okay? Okay, with all this information, I told you about indentation, I told you about scopes, primitive data types, data structures that is a little more complicated than primitive, okay? The name primitive, it tells you that it's primitive. It's only going to store like integers, floats, and so on. The data structures, it has more features, more functionalities, and how with all of this in mind, I have to say to you what is object-oriented programming, because all of this information that I introduced to you, it comes from this concept. And this concept is very cool. It's simple to say it, but it's complex to understand, okay? And I would say that Python was, it was developed in these fundamentals, okay? In these pillars. So what is object-oriented programming? It's a paradigm of programming. You program oriented to objects. What does this mean? Everything in Python is an object. And I don't know if you noticed, but when I was lecturing here, I transitioned from variables to objects very silently. I don't know if you noticed, but I changed the way I was referring to the variables, and I was starting to say objects. Because everything in Python is an object. What is an object? Well, object is an instantiation of a class. And what is a class? Okay, so let's go slowly again. We have primitive data types. We have primitive data types. We have more complex data structures. But these data structures, they are not primitive. Actually, they are classes. What is classes? Imagine that you want to describe a more complex object from the real world. Let's say this room here, the classroom. Okay. How can I describe a classroom to a programming language? Can I do this? It's not easy, right? Which type of information do I have to think to describe a classroom to a programming script in Python? It's very abstract, right? It's very difficult because, well, I can think of classifying the classroom as with the numbers of windows, the size of the windows, the size of the classroom, the number of lights, if it has a projector or not, if it has students or not, if it has a professor or not. So you can, it's very abstract, this information. And this concept tries to describe all of this information in programming language, okay? In script. So this is what it tries to do. It tries to encapsulate information inside of a single variable. And this single variable that has all this information, we call it class. That's it. So again, we come from primitive data types, then we go to data structures, and now I'm telling you that the data structures are actually classes. I even said that everything is a class, but we call it the most primitive one, just primitive ones, okay? So what is written here? What is trying to do this code here? Let's try to scrutinize this. So I wrote here class people. Okay, I did it in Portuguese, I'm sorry, but I will translate it, okay? So I wrote class people. So what I'm trying to do here, I'm trying to describe a person to the programming script, so to the interpreter. So to do this, I have to imagine that a person will have attributes and will have actions. So in programming, in Python programming, we call the actions methods. Again, the dots that I told you, okay? So we say it methods, but it's the actions of a specific object. And I said attributes, like for a person, it can have an age, it can have a name. So we call it attributes, okay? It's the characteristics of the object. So it's basically this. It's a way of encapsulating, describing the information for a complex variable in a template, like in a documentation, like in a document. It's this, okay? And whenever, so this is the cake recipe. So it's basically telling, like it's this sheet, like the documentation sheet. Look, there's a person. This is the name of the person. This is the age of the person. These are the actions that the person can do. It can say hello. It can say goodbye. You can say several things. So this is the template. And if I create a variable from the class person, I will call it an instantiation of an object. I don't call it more a variable anymore. I say object because it has more complex stuff inside of it. Okay. So it's basically this. So now here, this is not an object or a variable. It's just a description of this potential object. And whenever I create a new one, I will have a different person. So I will have different variables from the same description. Okay? So this is, and another way to think of it is you have your custom variable. You create your custom variable, okay? And you will describe what it has. So maybe it's a little difficult to understand what is written here because of the syntax, but I will translate to you. This one is called the constructor. Whenever you declare a new variable, which is an object, you have to specify to the constructor what are the attributes of this object. So here, remember the indentation. So here I declare class. So we have 4 spaces here, and what is inside this scope, this indentation, belongs to the class. It doesn't belong to the rest of the code. But in these 2 lines below here, I remove the spaces. So it means that these 2 lines doesn't belong to class person, okay? It belongs to the outer scope, okay? And here I'm writing João receives pessoa, which is this class. I'm calling the constructor. So I am creating a variable. I am instantiating a new object from class pessoa because it's written here, pessoa. And then here I wrote João, comma, 25. What is written here in def init, which is the construction? It's expecting a name and an age. And I'm writing here, I'm creating a new object called João with the age of 25. And then this is another method. I'm printing this information, okay? This is to show the information to the prompt. And inside of it, I'm writing João dots. Remember what I explained to you? Whenever you have an object and you write dots, it's going to try to search for an attribute or method. In this case, I wrote the method. Below here, I describe what the method will do. It's going to return a string. What is a string? It's one of the primitive types that I told you. It's a collection of characters, okay? It's a sentence. So here I wrote, hola, hello, I am, and then I write the name of the class, okay? So this is, don't worry about this now. This is a little more complicated, but it's basically telling that whenever you call this method, it will invoke the method from the actual object. So imagine that I have another object here with another name, baby Ana. And I say Ana.saudação, which is like greeting, right? In English, it will be written as greetings. It will say, hello, I am Ana, instead of João. Why? Because here it's calling its attribute, the name of it. So again, it's like information sheet for a verb. Okay? Was I clear here? Do you have any doubts? This is very complex. No? So this is the concept that works in Python. Everything is an object. Everything is this. So whenever you see a verb with dot, it's an object and it's accessing either an attribute or a method. Okay? Okay, so forget about the concepts. It's okay. So with the data structures, with the object-oriented programming, I will just make some, we'll introduce to you the libraries, okay? Basically the libraries, the ones that are essential to data science, okay? Most probably in the next modules, you will use NumPy, pandas, and so on, okay? The ones that I showed you before. So what is NumPy? As I told you, it's a numerical computational library. It's a library written to be as efficient as possible, to be used to make computation with loads of data, like billions of numbers and so on, to not take too much time of execution time. Okay, so what it does, it has its own class, which is called a NumPy array. What you see here, basically. So this is a library. For you to import it, you have to write import NumPy, okay? Usually, we like to abbreviate things in Python. So we write import NumPy S and P. So I'm telling the interpreters that I imported a library, And I will write just NP because I'm lazy. I will not write NumPy, okay? So whenever you see NumPy, look again the dot here. NumPy is NP dot. Again, so even the library is an object. So it's going to be a little confusing here. Everything's an object, even the library, okay? So I'm writing NP dot array. So I'm basically calling the constructor of the class array, which is NumPy array. So everything that was written in NumPy is inside the NumPy array. And here I'm writing in the constructor a list of numbers. Okay, it can accept a list of numbers. So I'm going to create a one-dimensional array, which is basically, you can think of as in the memory as several cells that you have the numbers. So there I wrote 1, 2, 3, 4, 5. So R1D, this is the name of the variable, the object, I'm sorry, that I wrote, and then I instantiated to be a NumPy array. So I put the numbers 1, 2, 3, 4, 5. So if you check the documentation of NumPy, not Python, you go to the website of NumPy, and then you open the web page to the NumPy array, you will see all the attributes and all the methods that it offers, which is a lot, and they are very useful. Okay. The main advantage that I would say that they have is vectorized operations. So it can make like operations in the whole vector. This doesn't make any difference from the regular Python and their native data structures. For small numbers, we have just 5 numbers. Okay. If I was going to do this in Python, I would have to, by one, I would have to access one value and multiply by 2. Here I'm multiplying by 2, right? The whole vector. In native Python, we would have to access one by one and multiply by 2. NumPy does this immediately. It basically broadcasts the times 2 to all the members if you write it like this. So it's much faster when you work with millions of data. Okay? And you have several mathematical methods. Again, you have the dot here. So imagine that R is a NumPy array. And then I write np.mean. What I'm doing here, I'm accessing the library, which is an object, and I'm accessing the method called mean. So it's going to compute the mean of this vector. This is very useful, no? So I have here several numbers. Imagine that they are the grades of a classroom. And then I just write np.mean. It's going to retrieve to you the mean of this vector. And I have others like np.sum, np.std. What is that std? Standard deviation, okay? Oh, but standard deviation can be, there's different types of standard deviation you have with the correction of Bessel and so on. You also have this in the documentation. So by default, it's going to be computed as one of the types of std. But if you want to apply the other one, just check the documentation. It's going to tell you, look, if you want to apply the other type, or the other formula with the correction or without the correction, you just see how it does, and then you just write it. It's going to work. Okay. You have np.max, np.min. What is that? To find the maximum value in the vector, to find the minimum value in the vector, to find the most common number. I think it's mod in Portuguese. I forgot in English. Yeah. The most common, the number that's most repeated in statistics. You can also do this, and you don't have to implement an algorithm to try to find the most common number. You just write the method and it gives you. So that's why Python is very good for data science. Okay, so now it goes to pandas. I assume that pandas you are going to use a lot, okay, in data science. What it does, so it's even a more high-level abstraction to handle data. It's well, when you see this, it's similar to a dictionary, right? But it's not a dictionary. The way you write it's similar. You have key pairs, values, and so on, but it's not this. Pandas, a data frame. So that's the thing. When I say pandas, it's the library, okay? And then it has the data frame, which is the class where everything is implemented, okay? Everything that you need is a data frame. What is the data frame? Think as a table, a big dimensional table. And then you can organize the data in this. You can make several not multiplications, operations and functions and so on. You can manage your data more easily. That imagine that you have to do this like using lists and tuples and so on. This is more complicated. So Panda does this for you, and it offers their attributes, their methods, and so on. Okay. So again, it's a library, it's an object, and you can use it. Okay. So they are called data tables in a more, how can I say, not formal way. They have some common methods. So imagine here. Let's see. I'm going to show this in the Jupyter notebook. So some common methods. Imagine that you have, let's see. Again, the information of the students in a course. Imagine that we have like the electrical department course here, the electrical engineering, and then we have all the students from all the courses, all the years, the ones that are advancing the classes, the others that are delayed and so on, they improved or something like that. So they have different types of attributes. Let me try to abstract this in the board. So imagine that we have, let's say, the name of a student, then I have the age of it, then you have the sex of the student, the gender, what year is at, how much it pays as a tuition fee, the nationality, and so on. Okay, and it goes. It can really goes to the limits. Okay, you can describe all the information that you can think of. Okay, in different types of data, like numbers, categorical values, which is the sentences, right, and the words. And this is what we call in data science and in data frames, we call it don't make confusion with the attributes from the class, okay? When we think in Python and classes, I say attribute, they are the characteristics. When we think in machine learning, in data science, when we have like some kind of table, the columns are the attributes. And then the instances of different people, like in this case, there are different people, we say observations, okay? So, like the name, we have, I don't know, P1, P2, and so on, different peoples, okay? People, P4 and P5, and then we have different numbers here, male and female, and so on, which year they are at, how much they pay, if they pay all the tuition fees, and so on. You can go really to the limits. This would be very difficult to implement with lists, dictionaries, tuples, and the other one, the sets. Would be very, very difficult. So what the Python engineers did was, okay, let's try to make this easier. Let's implement pandas, okay? So the data frame, you can literally pick this table and put inside an object and call the electrical engineering department, and that's it. Okay, so then you can access all the information from it. You can even, I'm just showing you guys, okay? You don't have to memorize this. You can have different methods, like you can say df is from data frame, it's an object, an instantiation of the class data frame. And I wrote dot head. What is head? Cabeçalho, or like the first lines of a table. Okay, it's going to print you the first lines, just for you to have a grasp of the data. You have dot info, it's going to say some general information. If you have numbers like age, it will print to you the mean, the standard deviation. It's going to compute some general stuff, okay? If you have like how many observations do you have, how many people do you have inside of it, and so on and so forth. So general information. I will show to you afterwards. And pandas is very good because you can filter data. And this is interesting because let's take a look at this statement. df, and then between square brackets, okay, this thing here, I wrote again df, another, again with the brackets here, with idade, which will be age, between simple commas, quotes, single quotes. And then I wrote the mathematical operator more 25. What is this? What the interpreter is going to do here? It's going to access the table, and then it's going to select the column H, okay? And then it's going to make it's going to filter the whole table to all the observations that it has an age more than 25. So it's going to give me as an output another data frame, but only with the observations where the age was more than 25. So I made an intelligence filtering, okay? This you can do with data frames. You cannot do this with lists, you cannot do this with tuples and so on. This would be a nightmare to do it with the native data structures, okay? So this is what it can offer. It can do other things. You can sort the values by age. So I can, again, we come back to the data frame, to the table here, and then I call the method sort values, and then I put as a parameter the column age. It's going to sort everything, but will take as a criteria of sorting the age. So by default, it does in a crescent way, but I can tell it to make in the other way around, okay? So it's going to order everything. You can also read external data. You can read data from CSV, which are comma separated values. It's common also in computer science and data science. Excel also files. You can read from Excel. We can read from JSON. JSON is a way of formatting values as well. It's a way of formatting values in a text file. Okay. You can also do all these things. You can also retrieve data from the internet as well. If it's correctly formatted, it can access the internet and extract everything and instantiate an object to put into it, which is the data frame. Okay, related to manipulation. Here, I'm going to take more. Here we have to pay a little more attention to the syntax. Until now, I was just trying to teach you the concepts, what it can offer, and so on. Now I'm going to show you what you can do to access different values, how to manipulate the data. Okay. I'm sorry if you cannot see it, but in any case, I can write it here. So for now, imagine that we have a list. We transition from data frames to the natives again, because I want to teach you some basic concepts for Python. Okay. So I wrote list receives, and then I wrote between the square braces, the 5 values, 5 integers. So we have a list of integers, 10, 20, 30, 40, and 50, okay? The interpreter will know there is a list because of the square braces, okay? How can I access these values? I didn't say this to you before. How can I do this? So you have a syntax. You have to obey how Python was developed. Similarly as the languages that we speak, we have to obey the syntax and the grammar and so on. So how do I do it? This method here, print, as I said, is just to show the information in the computer, okay, in the prompt. Inside of it, I just wrote the object, and then I wrote between, as soon as I finished the name of the object, I wrote between square braces again with a number. And what this number means? This is what we call an indexation, a direct indexation. I am indexing, trying to access a list of values by a direct index, by a number. How this works? This follows a convention from computer science, okay? Basically, I will draw here a vector, an array, okay? For people that are not, how do you say, familiarized with the name vector or array, think of as a unidimensional matrix from mathematics. Okay, matrix, you can have different dimensions, but you start with 2 dimensions, like, I don't know, lines and columns. An array or a vector in computer science is a matrix with 1 dimension, okay, just a line. So let's think that the list is a vector, okay, 1-dimensional matrix, and then you have different values. So how can I access a specific cell? We call it indexation. So the way the convention that it follows is that the first index, it starts with 0, always, okay? In Python, maybe in a different, like MATLAB, you start with 1, okay? But MATLAB is a different thing, okay? So the majority, the languages start with 0, okay? And then imagine here we have 3, 6, 7. We have 7 cells, okay? So it starts from 0 and it goes up to 6 because we have 7, right? So a direct indexation is like this. So if I want to access the first element of the vector, I wrote 0. But a thing that we have in Python, maybe not in other languages, maybe you do, maybe not, maybe not. We have also, how do I say, reverse indexation. We can write the negative number, like a negative number, to reverse access the value. Sorry, the vector. So if I write 0, I'm going to access the first one. If I write -1, I'm going to access the last one. If I write -2, I'm going to access the last but one of the vector. So this can be maybe a little more confusing at first, but it's useful when you get used to it, you see? So if I write lists indexing -1, I'm going to retrieve as an output 40. If it's 0, it's 10. Then we have something very, very nice from Python, which is called slicing. And this is important because usually when you deal with data science, people with time, they get, you have to do quickly the things and so on. This is very useful. Slicing is literally what the name says. It tries to slice a part of the vector of the matrix. So think that you have a cake and you want to slice a part of it, and then you want to retrieve the slice. So this is what it means. So imagine that we have this list. So we have, again, 5 values, 5 integers, and I want to retrieve this part of it. I want to cut this part and retrieve it. We have to slice these indexes, right? So how can we do it? We have to write this in this convention. First, we write the first index, then we write double commas, double points, and then we write the final index excluding. What does this mean? The first one is inclusive. So if I want, we have here 5, 6. Let me just make it similar as the other one. 1, 2, 3, 4, 5. Yes. I want to retrieve these 3 elements, right? So how can I do this? I know that the indexes are 0, 1, 3, 2, 3, and 4, right? To access this, let's say that we have this, I will say that this vector is called AB. So AB, I will try to do a direct indexation. And then I want these 3, I have to start with the first index, then I write double comma, and then I will write the last index, but exclusive. If I want to retrieve up to 3, I will write 4 here, because this is the way that Python handles indexation. The start of like a range of indexation, you start inclusive, so it's going to consider the first one that you write, but it's not going to consider the index that you wrote for the final one, okay? And this has a meaning, but I'm not getting into details, okay? But this was done on purpose, okay? So the first one, I write list 1, double dots, and 4. It's going to actually not retrieve up to 50, but actually to 40. Then I did something else here. I just wrote list, and then I wrote double, yes?
Sorry, just I was wondering, I don't know why they choose to avoid the last one. What if you want to pick the last one? How do you do it?
Then you write 5. Sorry. Then here is from 0 to 4, right? We have 5 elements. If I want to access the last one, you have different ways, okay? You can do it right.
Pick like, for example, 3, 4, and 5.
3, 4. No, we don't have 5 here.
Sorry, 2, 3, 4.
2, 3, 4. You have different ways. You can start with the way that is the most usual way, which would be 2 double dots until 5. You write 5, but it doesn't have 5.
Oh,
okay. You can do it another way. You can do it like I'm going to show you also Yeah, I think it has here. Yes, it has here. Yes, it does. You can start, but this is good. Is getting more
I
complicated.
understand. My question was how to pick.
Mhm.
You can put the number that
Yeah.
is not there.
Yes,
and
yes.
pick the last one.
Yes,
That's
yes.
okay. Thank you. That's-
Okay. Continuing, here, I wrote lists, and then I wrote double dots, and then double dots again, and then I wrote two. So what does this mean? It also follows, the convention from slicing. So the convention is, I will write it here. First, you write the index of the start. Then you write the end of the range, and then you write the step. Okay. The first one is the index that you start, which is inclusive. The second one is the index that is the end of your range for the slice, exclusive. And then the third one, which I omitted in the first one, because you can do this, it's going to understand. By default, is always one. You can specify the step. How much is going to skip? So if I write double dots, and two, what it means is that I'm going to run from the whole vector. It means that I'm going to start from the start to the end, but I'm going to go from into how can I say cells. I'm going to do steps of two instead of one. So it will return to me 10, 30, and 50. It starts with the first, it jumps one because it's steps of two, so 1, 2, and then also accepts this one, and then it's going to do it again because it starts from the start, the end, it goes in 2 and 2, so it's going to go 1 and 2. Was I clear this in here? Okay. And you can do it as well with negative indexing. Okay, Python has this, but with time, you get used to it. Here, this notation here is basically, I'm saying to the interpreter, I want you to run from the last and go to the first, but in a reverse way. So it's double dots, and then -1. So the step is -1. It's going to go from the right to the left. Okay. So in pandas it's a little different because pandas, as I said, is a class, and it has their methods of indexing or accessing information inside the table. You have different. I'm not getting. Actually, I'm using almost all of the time here to explain all this information. Okay, but you have different types. One of them, you just select the column. Imagine that I have a data frame that has two columns, which is denoted by these key values between simple quotes, A and B. So I have two. Let me write it here. Simple ones. B. So I have these two columns, and then we have different lines or observations. Here I have 1, 2, 3. And then here I have 4, 5, 6. Okay. So the way it was written, this is the way that pandas would understand. It would create this. Okay. I have different ways to access this information. I can tell to the object data frame to print to me because I put inside the print. Okay. Inside of the print, I'm just telling to the data frame access the whole column of A. So if I write just A between simple quotes, it's going to retrieve for me the whole vector. And print is going to understand it. Okay, I'm going to show this to you. It's a way. Another way, you have, look, the dots, you have a method to locate stuff, okay, which is called eloc or iloc. It's an iterator. I'm not getting into this now, but it's a different way to access it. So I am trying to eloc between, it has some parameters, 0, 1. What is saying here, what I'm trying to say to the data frame is access the element in line 0 and column 1, following the convention of starting with 0. So line 0 here, column 1, it would retrieve 4. Okay, so this is another way. You can also have another, this is another type of another method of also accessing information. You can access by labels, okay? But this is a little more complex. We don't have too much time. So for numpy arrays, we have different ways as well. As you can see here, I am just writing the object numpy array, which is the numpy array R, okay? And I'm accessing the line 0 and column 1 directly. So it follows the same convention from data frames, okay? And also I can do different slices for each of the elements. So I'm taking from lines 1 to 3, sorry, from lines 1 to 2, okay? The 3 is exclusive, and here from columns 0 to 1, okay? And then it would actually retrieve to me a submatrix, okay? And then we have strings. The strings is the same thing. The string is basically a one-dimensional vector as well. It's a collection of characters. So you access similar to a list, okay? For data visualization, we have matplotlib, as I told you, and Seaborn that goes, usually goes together, okay? You have different types of plots that you can do. It's really very complex. This you can go from a simple plot to a very complex plot, but it's easy to use and very hard to master. Okay, so here, what I'm doing here, I'm importing two libraries, Seaborn and PyPlot, a module PyPlot from matplotlib, and I also abbreviate it. So matplotlib, I will call it SPLT, and Seaborn is SNS. So here I'm just doing a simple line plot. I am calling PLT, which is the library, which is also an object, and I'm calling the method called plot. By default, I also put some parameters here. But how do I know what we have to put it there? How it's going to understand is the documentation. You go to matplotlib website. I'm not being lazy. It's literally like this that we work. If you have any doubts, you go to the documentation and see what it's going to expect for the as parameters for this method. So here is the x-axis, and this is the y-axis. If you don't specify anything else, it's going to expect a line plot by default, which is the most simple one. And it will expect the same number of values for the x and the y-axis, because it's going to try to do some kind of line, okay? And then you can modify it, like you can put a different title, a different label for the x-axis, the y-axis, and so on. And then I call dot show. It's going to show you a picture. It's going to generate a picture. And just to make like some comparison, I can do this also with SNS. What I'm trying to show you here is that Seaborn and matplotlib, they work together with data frames. So if you see this line, I wrote SNS.bar plot, which is a plot. It's a bar plot, okay, with different bars. And then I wrote here X. I wrote basically a label. And for Y, I wrote another label. And the third parameter, I wrote data receives df. What is df? Is an object of a data frame. So I didn't show the rest of the context, but the context is, imagine that I have data frame, that it has these two columns, and I'm just saying to it, look, I want you to plot a bar plot, and the x-axis is going to be category, and the y-axis is going to be value. And you are going to access these values from this object. So it's even more easier than this. So they work together, okay? So resources to continue learning, okay? Because this is a lot of information. I don't expect you to become expert, as I told you. So continue with the course, of course. You will have other modules that they will teach you about machine learning, data science, so on. But as I told you, whenever you work with programming, you have to consult documentation. So if you want to understand how the native objects and structures and so on that Python has, you check Python. If you want to understand how a specific type of thing working on NumPy, you check NumPy, and so on and so forth. You also have books, and you also have other learning platforms, okay?